Officials in a town use a function C to analyze traffic patterns. C of n represents the rate of traffic through an intersection where n is the number of observed vehicles in a specified time interval. What would be the most appropriate domain for the function? Okay, so we're talking about this function that we call C, and it's taking the input n and producing some output. So we could say C of n is equal to whatever. And we don't know what this is over here, but we don't care about what this is over here. What we care about is the function itself. And the question here is about what is the most appropriate domain. So domain is simply the values of n that can work for this function. And you might be thinking, well, how do I know what values of n I can put into this function if I don't even know what the function is? Well, we don't have to know what the function is because we have some, we don't have like an equation here, but what we do have is what the function actually represents. It represents the rate of traffic through an intersection, and n is the number of vehicles that go through an intersection. So think about that for a second. If n here represents number of vehicles, then the question about domain is, well, what values can n take on that this function could be evaluated at? Well, if you think to yourself, well, how many vehicles could possibly have gone through that intersection? We think, well, maybe there was one car. Maybe there were 2 cars. Maybe there were 10 cars that go through that intersection. Maybe there were 45 cars. Maybe there were 150 cars going through that intersection. What about 7.5 cars? Could you have 7.5 cars go through? Well, no, not really. You can't really have half of a car. So this idea of n representing the number of vehicles, this sort of item here, this thing here is something that we count with whole numbers. So there's 1 vehicle, 2 vehicles, 10 vehicles, 45 vehicles, 150 vehicles, but we can't have like 7.5 vehicles. We can't have like 2.67 vehicles. We can't have, 45.721 vehicles. So we have to keep whole numbers when we're talking about vehicles, or a lot of different things can only be whole numbers. So we know that we're dealing with whole numbers here. So if we look at our answer choices, we can eliminate answer choice 3 because we know we can't have like a half of a vehicle, half of a car. That doesn't make any sense. 1.5 cars. Well, what? That doesn't make any sense. So we can eliminate the one with half. Then we have to look at our other answer choices. Well, we say, well, looking at our other answer choices, which of these have values that could potentially be numbers of vehicles? Well, I look at this one here and I say, well, -1, -2. Can you have negative number of vehicles? No, that doesn't make any sense. When we're counting something like vehicles or cars, we start at, well, what do we start at? We start at 0. There could be no cars going through the intersection. That's a valid number. So 0 could be allowed, but anything negative, that doesn't make any sense. So we wouldn't say we have -1 cars going through the intersection or -2 cars. So these we can eliminate as well because they have negative values in this set, and n cannot take on negative values because it represents the number of something, and this something can only be whole numbers. So we're left with answer choice number 4 as the correct option because we have whole numbers 1, 2, 3, and the ... just means 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. And we could also have 0 cars. We can't have fractions, we can't have decimals, and we can't have negative cars going through the intersection. So with a problem like this, if we're talking about a function, but the variable represents something that is only countable with whole numbers, that tells you something about the domain. Well, the domain is what values that could take on. It basically tells you it has to be all whole numbers and not negatives either.